By late 2026, the operational reality for enterprise AI will invert. When the EU AI Act enforcement standards drop, the margin for error collapses. The regulatory framework establishes a maximum financial liability for noncompliance, set at either €35 million or 7% of a company's global turnover. This specific penalty structure moves artificial intelligence risk from the domain of localized IT problems to the desks of chief risk officers. The scale of the potential fines creates a threat to the existence of the firm itself. This threat was quantified in the May 2026 TAIGA Governance Gap audit, which stress-tested the infrastructure of 5 leading UK and global AI firms. The audit analyzed Quantexa, Faculty AI, Darktrace, Graphcore, and Tractable, organizations operating across varied sectors, from critical healthcare to semiconductor manufacturing. Each firm operates with distinct technical frameworks and specialized operational strengths. Yet, the audit reveals a consistent vulnerability shared across all 5. The audit identifies this weakness as a maturity gap, a systemic failure to govern the AI lifecycle from initial data ingestion to autonomous final action. When comparing documented safety policies against real-time performance, TAIGA measured a 96% reality gap. This is the distance between a firm's stated security measures and the deterministic integrity actually required to run these systems within the law. Bridging this delta requires moving past traditional point-in-time compliance audits toward a system of constant verification. Periodic checks cannot govern continuous execution. The 2026 compliance delta stems from structural engineering choices. Solving it requires a shift in how governance is coded into the system. This 3D enterprise tech stack diagram allows us to map the vulnerability, starting at the decision intelligence layer. Quantexa serves as the prime case study here, operating a £175 million sovereign AI contract with HMRC. On paper, Quantexa demonstrates a governed maturity posture. They utilize strict knowledge graphs to ground their large language models, minimizing hallucinations via contextual RAG and a dedicated agent gateway. But an architectural flaw in how the system handles entity resolution, the logic identifying discrete individuals or businesses, can bypass those grounding measures. If the entity resolution breaks down, the resulting wave of systemic false positives in tax risk assessments or anti-money laundering checks triggers high-risk deployment penalties. This vulnerability transfers to human-led consultation and the deployment of high-risk custom models, as seen with Faculty AI. Faculty AI maintains deep integration as a safety partner, conducting advanced red teaming for critical clients like the NHS and UK Defence. When an AI system serves critical healthcare or defense infrastructure, the liability metric shifts away from software bugs. Exposure is based on the accuracy of the decision intelligence provided to the client. In these high-risk sectors, grounding an LLM is insufficient. Any systemic failure in decision logic constitutes professional negligence, triggering maximum legal exposure under the 2026 framework. Moving down the conceptual stack to the active operational layer, we hit the threshold of agentic AI. Consider Tractable, a Tier 02 agentic system focused on automating complex insurance claims for major carriers. Tractable's operational risk is governed by strict contractual service level agreements. If their models produce systemic estimation errors, those errors pass directly into the insurance carrier's loss ratios. The developer is trapped in financial exposure based on automated outputs. This processing cycle diagram shows what happens when we escalate to a Tier 03 agentic system, utilizing Darktrace's active autonomous cyber response architecture. Darktrace natively unifies network and endpoint data to autonomously detect, target, and neutralize threats without waiting for explicit human permission. The prevailing industry assumption is that maintaining a human in the loop is the gold standard for governing this level of AI action. That assumption relies on a critical speed mismatch. Requiring manual human approval forces the autonomous system to pause. In a live cyber defense scenario, pausing for human input creates a bottleneck that effectively disables the defense. Conversely, removing the human entirely invites a different failure. Autonomous false positives can accidentally shut down critical, benign enterprise networks. For active Tier 02 and Tier 03 systems, traditional human-in-the-loop oversight guarantees structural failure. It leads to cascading operational downtime. Governance must also extend to the foundational bedrock of all enterprise AI, the physical hardware and software development kit layer. Returning to our 3D tech stack diagram, we shift focus to the bottom foundational block, using Graphcore, a subsidiary of SoftBank, as the primary example. Graphcore provides the sovereign AI stack. This is the enabling layer that enterprise deployers use to build and run their internal tools. Operating at this base level triggers Article 15 under the 2026 framework, which governs transparency and infrastructure failures. AI hardware is subject to strict product liability. A low-level compiler error or a microscopic chip defect at the Graphcore level can pass undetected upward, causing a high-risk deployer system operating far above it to fail. Financial liability permeates vertically, from base hardware defects straight up to autonomous agentic actions. Point-in-time compliance is mathematically incapable of mitigating this kind of continuous operational risk. To bridge the 96% reality gap before the end of 2026, organizations must adopt a specific engineering framework known as the Architect Mandate. Mandate 1 requires a transition away from human-in-the-loop oversight to human-over-the-loop. This is the only architecture that allows Tier 03 systems to manage autonomous response without incurring operational downtime, while still maintaining high-level human veto power. Mandate 2 is deterministic guardrail injection. Architects must utilize components like the TAIGA terminal block. By injecting rigid, unbypassable policy guardrails directly into the agentic reasoning loops, the system will physically halt unapproved logic escalation. Mandate 3 is continuous governance, risk, and compliance monitoring. The entire operational stack must be wrapped in a continuous governance fabric. This replaces periodic, retrospective safety audits with real-time oversight. Financial exposure for AI deployers under the 2026 legal perimeter is without an upper limit. To survive, enterprise systems require more than just auditing. Architecture is policy, and we must build for deterministic integrity.